Okay, a position vector. If you remember this, it's just really basic math. Okay, so it is x2. So think about this as the first set, this as the second set. So x2 is 2. Take away x1, which is 3. Okay, y2, which is 9. Take away y1, which is 6. Okay, so here's the position vector. It's -1, 3. That's all you have to do. Okay. Right, if you remember unit vectors, okay, unit vectors. So we just plug it into this equation here, okay. Now, first of all, you're finding the magnitude, okay. You've got to find the magnitude of this particular vector. So this is the equation put it into. It's just this. So that's going to equal the square root of 16 plus 9, which is the square root of 25. So that equals 5. Okay, that's the magnitude. The magnitude of this vector is 5. Okay, now remember the unit vector. Remember how we do this? U equals 1 over the magnitude multiplied by the vector. So we're doing this 1/5 multiplied by the -4, 3. So this is just, here's the answer coming up right now. Okay, so -4/5, 3/5. And that is the unit vector. Okay? Right, let's look at the last part. Right, vector in the form W1. Well, I've changed this to the letter V. It doesn't really matter. I mean, we've seen V, and it doesn't really matter what this is. V1, V2, whatever. Okay, so remember, this is just the equation. So what we're going to do is put this into here. Okay, so let's take a look. So, right, all we have to do is find out what we've got the magnitude. Okay, so here we go. So we have the magnitude. It's 2. So I can write that like that. Now then, cosine of theta. Right, the cosine of 60 is 1/2. Okay, and that has the I. Plus the sine of 60, which is √3/2, and that's the j. Okay, so all I'm going to do is multiply that by 2, and we get I plus √3j, because think about it, the 2 there, it'll cancel that 2 there. So that there is the actual required vector. Okay, there you go. That's you written it in that form. Okay, so let's take a look at the next one. Okay, remember this? This is side, side, side. Using the cosine rules, it's 7.2 to try and find out the values to the nearest tenth. Okay, now actually this, I'm actually going to scroll to this because I've realised this is actually in the book. Whoever's done this has taken an example directly from the book. It's on page 657 from 7.2, but I'll run through it. Okay, so 2, A, B, well, let's take a look like this. I'm going to do this. Okay, so cosine, if I rearrange this, then cosine of C is going to be A squared plus B squared minus C squared all over 2AB. I'm just rearranging for cosine C. You can take a look in the book, I say on page 657 on section 7.2. So cosine of C is A 3.1 squared, that's A, plus 5.4 squared minus 7.2 squared. Okay, all over 2AB. 2 times 3.1 times 5.4. That comes out to be -0.39. Okay, now you can put that in your calculator. Remember the inverse. What's the inverse of -0.39? Apparently it comes out to be 113 degrees. Okay, so we have the angle of C. Let's erase all this. Okay, now once we have that, we can use the sine rules like this. Sine, I'm just going to let the book does it. We did it upside down. Sine B over B equals sine C over C. So we know what B is. It's 5.4. We know what C is. it's 7.2. We know the angle of sine C, okay, it's the sine of 113 degrees. Okay, so if we are looking for sine B, we're going to multiply both sides by 5.4, okay, to get rid of that. So you just put all that in your calculator. You will get that B equals, okay, you're going to get B equals 43.7 degrees, okay? And now it's just a question of filling everything out. If that means A is going to be 23.3 degrees, okay? And that's it. So you've got the three angles because you've already got the three sides. So like I say, so take a look at page 657, section 7.2 for that one.